Alright, for this one you have two inequalities and the word "and" in between them, which means at the end both of them have to be true. So I'm going to solve the first inequality. The first inequality, I'll write it over here, is negative 2x is greater than 4. To solve for x, I'm going to divide by negative 2. And when you divide by a negative, you're going to switch the symbol. So now it's going to be less than. And positive 4 divided by negative 2 is negative 2. So that's the first inequality. X is less than negative 2. So I'm going to use this empty number line down here. If I go to this option F, empty number line, here's negative 2. Less than negative 2 gets a parentheses and an arrow all the way to the end of F. Now I'm going to change colors to do the other plot, or the other inequality. So the other inequality is x plus 3 is greater than 0. So when you subtract subtract 3, you get negative 3. You don't have to change the sign, and you get x is greater than negative 3. So I'm going to come down to this same plot, and here's negative 3. Greater than is to the right with an arrow to the right. And what I'm looking for is the area where they're both true. So over here, only the red line is true. Over here, only the blue line is true. But between negative 3 and negative 2, you see both lines at the same time. So our answer is only between negative 3 and negative 2, and they both get parentheses because neither inequality has a line underneath. So the solution set is negative 3 to negative 2 with parentheses on both sides, which would be graph B. And again, you only choose the section where they're both true, so you can fully graph both of them individually, and then you look for where they both overlap. And that's because of the word "and" in between. For the next problem, it says "or." So it's pretty much the same problem except it has the word "or." So again, I'm going to solve each one separately. The first one is x plus 4 is greater than 7. I'm going to subtract 4, solve it just like an equation, and x is greater than 3. So I'm going to graph again. I'm going to use this empty graph down here. I'm going to go to positive 3, which is halfway between 2 and 4. It does not have a line underneath, so it's a smooth parentheses, and greater than is to the right. I'm going to change colors here. We have 2 minus x is greater than 7, so I'm going to move that 2. We have negative x is greater than positive 5, and we have to divide by negative 1. When you divide by negative, it changes that sign. So it was greater than, now it's less than negative 5. And I'm going to graph that down here as well. So here's negative 5. Less than is to the left, arrow to the left. And again, a parentheses because there's no line underneath the inequality. So for the word "or," the word "or" means one or the other or both. And you can go back in your notes, we wrote all that down. One or the other or both. So in this case, everything that's graphed is true. So from negative infinity to negative 5, that's part of my solution. Remember, infinity always gets parentheses. The negative 5 will get parentheses because, again, there's no line underneath here. Union, that letter U, and another parentheses from positive 3 to infinity. So it's both parts of the inequality. And the only graph that has that is graph D. Negative 5 back, positive 3 forward. Alright, the next one I think is just a regular, it's absolute value inequality. So for an absolute value inequality, again, this would be in the video that I made, so hopefully you were able to watch that video. So you have the absolute value of 4 minus x is greater than 8. You want to solve it like an equation first, like when we split the two options like a regular inequality, absolute value. So 4 minus x could be positive 8, or 4 minus x could be negative 8. So you're still going to get two answers. Remove that 4. Negative x equals positive 4. Divide by negative 1. X equals negative 4. That's one of your what they call anchor points. And then we're going to solve for x again. Minus 4. Negative x equals negative 12. Divide by negative 1. X could equal positive 12. So negative 4 and positive 12. So on the number line, we're going to plot negative 4, positive 12. And then you have to go back and look at the inequality. Greater than is always outside the two values. Greater than 8 would be far away. So it's always going to go for the outside of 12, the outside of negative 4. And then depending on the style of the inequality, again, if there's no line underneath, they'll both get a parenthesis. So it's from negative infinity to negative 4 with the parentheses. Then you'll put the U for union, and then positive 12 to infinity. So again, I'm going to write it down here so I have more space. Negative infinity to negative 4, union, positive 12 to infinity. So again, if it's greater than the number, it's outside the two values, away from the two values. So it's always two pieces of the interval, which looks like it's option A. Believe the next one is less than. Yes, so for less than, again, you're going to solve it like an equation. So we have 5x plus 7 is less than 8 in absolute value bars, and you're going to split it into the two options again. 5x plus 7 could be 8, or 5x plus 7 could be negative 8. Solve. 5x equals 1. Divide by 5. So x could be 1/5, which is just above 1. And then solve here. Subtract 7. 5x could equal negative 15. Divide by 5. X could equal negative 3. So those are what we call your anchor points. So negative or positive 1/5 is just above 0. And then negative 3 is down here. And then you go back and look at your inequality sign. This one is less than. For less than, it's between or inside the two values. So if you think less than little, it's the distance or space between the two values. And then again, because this does not have a line underneath, these both get parentheses. If it had a line underneath, they would get brackets. So it's only between negative 3 and positive 1/5, which is choice D. And the interval would be parentheses negative 3 to positive 1/5. So less than is between for absolute value. Greater than is outside for absolute value. All right, and then question 5, that is just a regular inequality. So from here, we'll distribute that 3. It's just a single inequality. 12a plus 12 is greater than 9a plus 24. This time you want to keep variables to the left and constants to the right, so your inequality is read correctly. So we're going to move that 9a. That's 3a plus 12 is still greater than 24. Then we'll move the 12. 3a is greater than 12. Divide by 3. And a is greater than 4. So on the number line, greater than 4 is from 4 to infinity. And because there's no line underneath, it's an open circle. and a parentheses on the interval. So it's 4 to infinity with an open circle, or you might see it as a parentheses and then a line. So always think greater than to the right towards positive infinity, less than to the left towards negative infinity. And the less than sign kind of makes an L, so you want to think left. Less than is to the left. And then you can remember greater than is to the right. All right, I think that is all your questions. Hopefully that helps with how to draw those number lines. If you need anything else, just email me.